My name is Carlos Hinrichsen. I live in Toronto since 2017, but I'm originally from Chile. I have more than 10 years of experience in forecasting and analytics in the mining industry and the financial industries. Currently, I'm the director of education at McMaster AI Society, and also I'm a senior analyst of AML risk analytics at Scotiabank. Well, there you can see if you want to connect with me. There's a LinkedIn link, so I can share it afterwards in our channel. And of course, the tutorial that we're going to see today, it's in this GitHub like channel. Okay, so so let me tell you briefly about my journey using geospatial data. So I started all my journey related to analytics and data science in R. So using R, when I had to do some plotting using the latitude and longitude data, so it's geospatial data, the first thing that I went through, it's one plot that it's part of the ggplot library, that is QMplot, and that it's pretty cool that you can plot like some analytics using locations. But the thing about this is it wasn't flexible enough. So it's just a picture, you know. So I wanted to understand if we can have like something more interactive, that you can like move the map as we can do in Google Maps, for example, and if we can plot some information relevant if we are trying to solve data science some data science problems or something like that. So after that, I went to what it's called Leaflet and Shiny Apps. All this is in R, yeah, but I wanted to show you first. So Leaflet is the library when you can create like interactive maps in using R or R Studio. And the thing is, it's pretty cool because you can like move the map as well as in a Google map, but it's completely free. The difference between this library, that it's the same thing in Python and R, it's that you can have like some features, of course, limited features in comparison to Google Maps, but it's completely free. In Google Maps, you can you need to create an account and put a credit card because there are some services that are not free. So maybe you can go that way if you want, and you can stay with this. We're going to see, in fact, the Leaflet. Okay. So in the Shiny app, it's a web server application when you can like, if you're working with maps, you can create like your web application and put the information there. But that depends on your topic or what you wanted to do. So and using Python, the main difference it's the same Leaflet library, but the library is called Folium that uses Leaflet. And the thing is, it's pretty interactive. It has basically the same features, and my main idea for today is to show you how to create these maps. And if we are going to put some data using a clustering problem, using data from the UCI machine learning dataset, and if you want in the future, we can discuss with Adam this afterwards. We can do another tutorial that how to create these maps using, for example, Flask. It's not part of this tutorial. So let's start right now with the tutorial. Just for you to know that was the thing that I was mentioned, the ones with R, the Leaflet. You can create interactive applications. This is like my account using Shiny Apps. When you can create something like this, when you can have that's the idea, that the thing that we are going to do today, that you can have like a map as Google Maps, and you can plot information or stuff like that, or use like a data science method to get some insights and things like that. This is the web page official web of Folium. I can share it like afterwards. And now we're going to go straight to a Jupyter Notebook to do the tutorial. So the first thing that I wanted to, and it's going to be it's going to be an applied like tutorial. So we're going to go straight to the code and to do some changes and see what is happening in our map. So the libraries that we're going to use from this specific tutorial, we are going to use some methods from scikit-learn and pandas and this volume library that of course you need to get installed in your environment if you're using like Anaconda or so once we have all this the libraries and the methods already loaded, imagine, for example, let's go to the introduction of maps. Imagine that we want to see a map that is centered in Union Station here in Toronto. So the first thing that we need to do is to get its coordinates. So if you have the coordinates, you can define an object related to the coordinates. This is in fact the coordinates of the Union Station, and then you can create an object using a map using this method that is following that map. Using the location, you can select a zoom star and which kind of map do you want to show. So that is called the tiles here. So if I can run this part of the code, we're going to see this. But it's basically a map that is centered in Union. This is Union Station, and I can move it to the right, to the left. I can zoom in. If no, I'm sorry, I'm the full zoom. So I can zoom out. You can zoom out, and see all the Toronto Islands and other sites like that. So that is our first approach that we can do using this. So we're just creating the basic map using volume. Of course, if we want to change the zoom star, we can just run the code again, and if we can see it's centered in Union Station, the map, but of course the zoom is completely different. Okay. So the next thing that we're going to do is the following. So, well, another thing that we can do is we can save this map as an HTML that we can afterward, if we are sorry, we are creating an application and we need to pull some information from a HTML, we can use this file and plug it in a web application. Or and in fact, let me tell you like something very short. So I think it was 2 years ago, I was applying for my driver license here in Toronto. And when I wanted to select my driver center to do the test, they were using the same environment with the leaflet with the leaflet maps. Just for you to know, they are using this kind of stuff. So, so what if we need another kind of map representation? Because the tile or the map representation that was by default is the OpenStreetMap, that it's this one. Okay. What if we want to see another representation, like statement terrain? You can see all of different tiles in the documentation of the volume that is I'm going to share afterwards. So if I run this and creating the map object with the same location of, sorry, this is not McMaster University, this is the Union Station. I can press enter, and I'm going to see a map that is centered in Union Station, but the map is different, you know. And I can do exactly the same with another ones. I'm going to show you like maybe it's not useful, but the statements watercolor. Sorry about that. And of course we can it's a watercolor like picture of Toronto center in Union Station, but maybe it's not useful. It's just it's a pretty way to see the city, but it's not good enough for us in the thing that we want to do. So now let's see some landmarks and attractions of Toronto, like the Ripley's Aquarium, the CN Tower, Scotiabank Arena, Rogers Center, and Billy Bishop Airport. And we will use an icon to show the places. So we can put some icons to represent some locations in using volume, and the list of icons that are supported. I can of course I can share this website also. There are different kind of icons that we can use if we want to represent, for example, a restaurant, or for example a port. Imagine we want to locate the ferries, or for example a car dealership or something like that, you know. And And having the coordinates of these locations, I can define a color palette to color the locations with the different colors, of course, and I can create a map center in Ripley's Aquarium. That is our location of the Ripley's Aquarium, and then we can add with this 4 all the different coordinates with the icons and the signs to our map. So in general, the how volume works is you can create an object, and then you can add some information in the merge, because we created the map here, but with this 4 we are adding some other information to our map. So if I enter this, we're going to have like a city of Toronto that is centered in Ripley's Aquarium, but now we can have like all these icons with the 5 places that I mentioned above, the Ripley's Aquarium, CN Tower, the Scotiabank Arena, Royal Centre, Billy Bishop, and there's the Billy Bishop Airport over there. Now we have like here Royal Centre, Ripley's Aquarium, we have the CN Tower, and over here we have the Scotiabank Arena. Yeah, but so far maybe it's not that interesting. So finally, we will, for example, we will add the respective web pages for each of these landmarks and put the names and create another map where I can use a pop-up to show the web page and a tooltip to show me the names. And using the same process to create the map first, centering some location, and then adding these markers. Okay, that is the name, the markers. So if I can run this, I will have this. It's the same. Of course, it's the same with the same colors, but if I put the name is, if I hover over all these different icons, I'm going to see this says Royal Centre, CN Tower, Ripley's Aquarium, Scotiabank Arena, and if I go to the Billy Bishop Airport and I press this icon, I'm going to have like this hyperlink, and if I open this, I'm going to go straight to the web page of Billy Bishop Airport. And of course, if we want, we can save this map as a Toronto HTML, and if I can, I can open it, and I will have like this map this way, and I can do exactly the same thing. I can push Royal Centre and then get to the web page of the Toronto Blue Jays Royal Centre. Okay. So let me continue with this, and maybe afterwards we can go straight to the questions, Adam. So the idea is now we're going to do some hierarchical clustering problem using these maps, and we're not going to go through all the theory behind. The idea is to create this model using this clustering method and to show you what you can do. So the dataset we're going to use is the real estate valuation dataset that it's in the UCI machine learning repository. That it's this one. And the good thing about this is they have like location of a city in Taiwan with other features, of course. So the dataset information, we have the house price, transaction date, the age of different houses, because this is a real estate valuation data set, the distance to the nearest subway station, the number of convenience stores nearby, and the latitude and the longitude. So, and then the thing that we're going to do, I already have this in my local folder. I'm going to upload the data, and we're going to do some cleaning and transformation. In particularly, we're only going to use the house age, the distance to the nearest subway station, the number of convenience stores to do the clustering. Of course, if we are doing some, supervised learning using prediction, we should use all the data or other part of the data. So the columns that we have a bunch of columns of different variables that we're not going to use, and I'm going to drop all the information that we're not going to use. And if I see the head of my dataset, we have the house age, the distance, number of convenience stores, and then I have my latitude and my longitude. So now, just I don't like this name, so I just changed the names to another ones that are more neat, like HDST, STR, lat, and longitude. And the thing that we're going to do now, it's now we have different columns related to the longitude, the latitude and longitude, and we're going to create a following map that is going to be centered in the mean of the latitudes, or the whole latitude data set. We're going to calculate the mean, and then the whole longitude data set, we're going to calculate the mean, and that is going to be the center of our map. And then we're going to add marks to identify each house in this map, where the tooltip is going to be the age. We can do whatever we want with the data what we have, but in this particular case, we're going to do just this. So if I create the map, I'm going to see, of course, here we have a lot of more information that the example of the internal. So that this is a map of a city in Taiwan, if I remember well. If I zoom out, you're going to see, if I zoom out, zoom out, you can go with, it's the same thing as using Google Maps. So you can zoom out, and that's it. You can see like all the globe. Okay, I will zoom in. I think it's going to be faster if I do this. Zoom in, and then we have the locations of all these houses in this city of Taiwan. If I put myself over the different locations, this number is going to be the age of the house. So this house it has almost 40 years old. This 28. This one it's brand new. This one is 16 years old, and so. But the main idea here for the exercise that we're going to do is, in terms of the number of convenience stores, the how close we are to the subway stations, and the age of the house, if we can create or we can identify which houses are similar than another ones through clusters using hierarchical clustering. So the thing that we're going to do is, it's first of all, we in method like this one, because we're using measuring distance, in general you need to do some pre-processing, and in fact to scale the data. That is the thing that we're doing right now, and in this part of the code. And after the pre-processing, we have the age, distance, and numbers of stores. This is the head. There are the first 5 rows, and they are already scaled. Okay, so afterwards, if we have all this data that is scaled, we can create that object that is called cluster, and that use the agglomerative clustering from scikit-learn, when I can define the number of clusters equals to 3. The how to measure distant Euclidean. The linkage is, this one is try to avoid or reduce the variance when we're doing the clustering. Then this the information of this method, when we are when we are solving this, then the the results, we can put it again in our data sets in another column to identify the different clusters. So running this part of the code, and then looking the information of this data set, we can have now another variable that is called clusters that has the same numbers of observation, 414. And if we can see the table, the first 30 observations, we can see this is the number of the cluster, considering the method that we just ran using this variable. So the observation 0 is related to the cluster 1, the observation 1 to the cluster 2, and the third one, it's called the cluster 0. It's the fifth observation, and we can see like the 3 clusters are related to the data after running the method. So once we have that, the idea is to try to recreate or to plot the clusters in the map that we just showed above. So we're going to create another following map with the location, the same with the mean that we calculate before. And the thing is, we're going to plot the different clusters, and if the cluster is number 0, just plot the icon as red. If it's the number 1, the blue, and otherwise the orange, and then put all that information in our object that we created before. And this is the same process that we have been doing with the previous plots. So if I can run this, of course, I just choose like the number of clusters equals to 3. In general, you need to test different number of clusters and run another analysis, but that is not the purpose of this tutorial. So if we can see now the data, if we are choosing the number of clusters equals to 3, we can, and putting that in the locations, we can see some trends about the houses. We can see that these houses, the blue ones and the orange ones, are mostly in the center of the city, and the ones in red are in the farthest part of the city. So when we are creating like this cluster of, if you want to say another name, maybe a neighborhood, we can understand the 3 types of neighborhood in terms of age, distance to subway, a number of convenience stores, and we can see the ones of the light blue or blue are on the somewhat in the left part of the city, and the oranges on the right part of the center of the city. So then, if we are okay with this, we can do the same thing. We can save this object as an HTML, and then if I'm running an analysis or a previous analysis, I want to share this with my boss, that he or she wants to see if the results make sense, I can share this HTML, and he or she can run it, like zooming up, zooming out, try to understand if it makes sense or not, you know. So my main purpose of this tutorial is just you to understand and to get you curious about understanding, or to know a little more about how we can use geospatial data, not only to show you things, but also to run maybe data science method that uses like these locations, and to provide insights in your, I don't know, in the work that you're doing, or if you're doing some assignment or things like that.
So Eric has asked, can Folium link geospatial data with geodemographic data, such as demographics, spending habits, and social values? A company that does this well is Environic Analytics, but through its proprietary software that has a good point-and-click interface. It would be great to find a way to do it with a free programming language like Python.
Yeah, I think of course you can use all that information, and Eric, and the good thing is using this library, of course, is completely free, and that's the idea. What I was telling Adam, that maybe in a future session I can continue from this point to do a web application in Flash completely free, because it's just this library. The good thing about this is it's completely free. Of course, as I mentioned, it doesn't have the same features as the Google Maps application, but I think it's good enough in terms of most of the people who wants to do with geographic data, you know. So in fact, let me tell you, in fact, in my job at Scotiabank, now I'm integrating geographic data with Power BI in order to understand the same thing that you are mentioning, Eric.
Harish has said, I spent some time here about GeoPandas for geospatial data. What is the difference between GeoPandas and Folium?
I don't have that kind of experience about the GeoPandas, but I haven't worked with GeoPandas so far, but I don't know if it's as interactive as this one. I think that could be like a difference, but I don't know. Harish, I don't know for sure about the differences, but because I want to start like this journey, I found this and all the things that you can do with Folium library, but of course it should have like the same similar features, but I don't know if it's interactive, because that is the main difference. When I show the example of R, in R you can have like this QMap, QM plot method, but it's like in a static view. It's not as interactive that you can going back and forth and just to create interactive things. But that's it.
Ali said, can we use this library for real-time locations like showing car locations?
Yeah, I think so. Because I think it's of course. Let me tell you this, because I mentioned that in Google, if you want to use Google Maps, you need to have like an account and put your credit card. In fact, I'm working on a project using Google Maps, and using Google Maps is more like a real time. I think it's easier to do that, but I don't know if there's any problem to do that. I think the main problem should be or could be to pull the information from another data source that it's like in real time. Of course, in real time, the most real time that we know about the geospatial data, it's Google Maps. But if you cannot connect to Google Maps, maybe you can try to figure out how to connect to another data source. But otherwise, you can try to use like Google Maps. I think in Google Maps, with the different services, you can have a limitation. Let me tell you, if you want to understand or you want to get the postal code of an address, for example, you can have like a free consultations up to certain number. After that, they're going to charge you from each consultation. So maybe it's this. Maybe you can try to understand if you're not using too much information to do something like this. Maybe you can put your credit card in using Google Maps, but maybe they're not going to charge you anything because of your data that you want to pull.
Yan asked, what map engine does Folium use? My apologies if you already covered this and I missed it.
No worries, no worries. As far as I understand, Folium uses the leaf flat map engine. That is the same one that uses R. You can find, of course, you can go to the documentation of Folium, and in Folium you're going to get some you are going to get some information about Folium. But if that doesn't work for you, you can go to the documentation of Folium in R. That is the original library. But as far as I understand, the map engine it's a leaflet. Sorry, so I was saying Folium back and forth. No, the Folium it's the library that you need to download in Python and uses leaflet maps. And the leaflet maps are the same ones that you can use in R. So as far as I understand, the map engine it's leaflet for the Folium use in Python.